Says anything? All right, so you have just seen a video where a cone, okay, right, was used to fill up a cylinder, and we were expected to use that information, all right, to work out the formula for the volume of the cone, all right. Why are we pouring water from one thing to another to work out volume? Yeah.
Because the volume is actually what fills the inside of the shape. So
Yeah.
you can use water as a good example to show what the
Yeah, water works, doesn't it? Yeah, water works, fills up the space, taking up the shape. So we can then, water is really useful because you can take that volume and put it into any shape, can't you? And compare. So that's the thing, you can transfer from one to the other. Other options for working out volumes of funny shapes would be to use what? Salt. Remember we did salt last year? Yeah. Sand.
No, you just take away.
But we need a material that we could pour into a different shape, wouldn't we? That's the thing, it doesn't really matter. Oh, I get you. Okay. Rather than being able to convert one to the other, it's a solid shape. Yeah. Okay, I get you.
You can use sugar.
Yeah, sugar. Anything like that, right? Anything that can fill the gap and change from one shape to the other. So what did you notice then? First of all, Owen, what was one of the dimensional things that we noticed? All right, before that bit, just the very beginning bits, about the dimensions that must be. What were the first two things it showed you? Exactly the same in height and... Right. So the height... Why am I going wonky? All right. So the height of the cylinder has to match the height of the cone, yeah? Perpendicular height, right? So you notice the cone was exactly the same height as the cylinder, right? That was important, right? What was also the same was the diameter, right? So the diameter there was the same as the diameter there. Or maybe more importantly, the radius, because we want to use a radius. Yes, Liz?
For the net, wouldn't it be the same except for just take out one of the circles for the cone?
It's a good question. We'll come back to that when we do surface area, but we'll see. We'll see. All right. But what we wanted to be able to do, we want to be able to do the volume of the cone, all right, rather than surface area, but we're going to do volume. And what we noticed was that if I fill up the cone and pour that volume of the cone into the cylinder, how many times was it done? 3. Okay. So we need to do this times 3 to give me the cylinder. All right. By the way, on the video clip, it wasn't quite filled up at the top, actually. How do you account for that?
Because they didn't fill the cone up to the top, like each time.
Or they spilled.
There was spillage, there was not filling up quite to the top.
We also know that it is exactly 3 because the first time he poured it in, he got it up to the little line.
But that also relies on the fact that those were exactly a third each time. But there were lots of little things that count up to a big thing, right? There's sports people amongst you that dealing with all the small things builds up to a big thing. So there was some spillage every time. There was the fact that, well, one of your questions on the My iMaths, one of you said, I think it was Jay, do I just assume that it's got no thickness? So what about the cone? Do you remember the pipe, yeah, that was used for guttering, it said? you didn't take into consideration the thickness of the pipe, did you? It was just here is a half a cylinder. All right. In reality, that would have a thickness like the other one that the other one that we were doing, the hole, the pipe with the hole under it. So in that video, there was a thickness of the cone that took up some of the volume. The water that was being transferred, you never got all of it. So all those tiny little differences added up to quite a big one at the end, didn't it? All right, but you get the idea. So that's where the criterion D side of it comes in. Because what in criterion D do we need to be aware of?
The anomalies and what.
Well, what is it in criterion D that we're actually asked to think about? Yeah, degree of accuracy, yeah? And does your answer make sense, yeah? So it's fine, the answer's fine because of all these things, and the degree of accuracy that I need will be affected by losing water and that kind of thing. So then we've got to come up with the formula. So what did you do? Well, we've got the volume of a cone times by 3 is equal to the volume of a cylinder. All right? But that's not a great way of looking at it because I don't know the volume of a cone. That's what I want to know. But I do know the volume of a cylinder, which is
Pi r squared h.
pi r squared h is the volume of the cylinder. So the volume of the cone times 3. But let's say what's the volume of the cone? How, instead of doing times 3 on this side, do I get it on this side where I can use it? Yeah? Okay. Divide by 3 or times by a third. All right. That's the third time today that I've come up with the link between dividing by 3 and multiplying by a third. I started it with the M2s earlier. All right. We discussed the same thing. And I said to them, yeah, even some of the best mathematicians in the school don't know that dividing by 3 and timesing by a third are the same thing. Right? So it's good that you do know. And I checked it with my M4s actually. No, my M5s. And I didn't actually ask them, but a question came up and they were a bit like, oh right, yeah. What was 1/2 divided by 5? Well, it's the same as timesing by a fifth. All right, so it's always there. So what have you got in your formula booklet in the textbook? What does it say at the back, page 192? Does it say times a third?
It's 1/3 times
Yeah.
pi r
So
squared.
1/3 of pi r squared h. So that's like saying, instead of having it this way, we've got the volume of a cone is 1/3 of the volume of the cylinder. Rather than saying the volume of the cone times 3 is the cylinder, we say the cylinder divided by 3 is the cone. Yep.
Couldn't you just put, like, wouldn't it be easier to look at if you just put it over 3?
Means the same thing, but actually, then we've got all multiplication written in our
Oh, yeah.
formula, rather than a couple of multiplications and then a division. It doesn't really matter, but you will see it in formula booklets as 1/3 of. Yeah? Got it? Desmond?
I know enough to know my yet, but
We're about to.
It says pi r squared plus pi r s.
Okay, well, we'll come to it in a sec, but are you happy with the volume of a cylinder?
Yeah.
Cone, sorry. Right, first thing you want to do then is put that in your formula booklet, and then we'll talk surface area. Recording. So with our cone, here's my circle base, here's my cone. Now something to be aware of is that we've already looked at, well, this is the radius of the base, okay? This here is called the height of the cone. But this distance, remember the one I was picking up here? All right? That is called L, which is the
Length.
slant height. So this is the height in H, but this is the slant height and it's called L. All right? Thank you, Jelena, for that inappropriate comments while I'm trying to teach people. It's all right, it will be on YouTube now. I'm going to tag it, hashtag inappropriate. Hashtag Jelena and Adriana.
We call it stupid.
Right, so, formula. So, can you, in the textbook, can you tell me what the formula for the surface area of the cone is? Go on then, Desmond.
It is pi r squared plus pi r squared. Pi r s.
By L.
S. Well, it says S.
Oh, is it an S in the book, is it? All right, so where does that come from? Well, what is the pi r squared?
Oh, that is the circle.
That's the circle,
This one.
the bottom bit.
Yes.
Yeah,
Or
the circle. Now, a little bit more, and we're not going to bother going into how at this stage because it's a little bit beyond Liam. If you want to keep your hands to yourself. Hashtag inappropriate.
Caught again.
I hate you.
The pi RL comes from the fact that we have a bigger circle, but not all of it. All right? So you remember, here's the bigger circle, and we chopped a chunk out to make the cone. So what is L?
No.
Well, L is the
height.
slant height, which on the bigger circle was that radius of the bigger circle, wasn't it? An L. That's why I keep saying it.
Wait, so is the Pac-Man thing the net?
Yes, this is the net of a cone. All right. What does this R relate to? Which
Radius.
circle?
The small one.
The small one. Good. Okay.
Totally.
So if you're interested, you could look at why the area of this Pac-Man shape ends up being pi RL. I'm not going to go through it. It's unnecessary for us at the moment. But the pi RL is what would give you the area of this. Okay? Right. So you would need the R of the circle that it folds up into. And the L is then the radius of the bigger circle that it opens up to. But when we actually look at our cone, L or S, whatever's in the formula booklet, is the slant height. So, the slant height of a cone, remind me, is
Oh.
L, and it's the distance on the outside, it's the sloping height. What's longer? The height of a cone or its slant height? It's slant height.
Because yeah, it's straight and then it would be
Yeah.
a little longer.
Okay, so that's the formula for the surface area of a cone, and basically, without giving you all the information, that's where it comes from. Now, I set my M5s a task of doing their egg drop challenge, and they had to know exactly all the surface areas and volumes of all the shapes they used, and they had to have more complex shapes. So some of them had to know exactly how to construct a cone with a certain surface area. So they had to know how to make a cone without just randomly folding up a bit of paper and then shouting through it like it's a trumpet, right? So this is the start of it. Hashtag inappropriate Jelena this time. Right, so you now know where a cone comes from, what the net of a cone looks like. So you've got 4 minutes to make sure that your formula booklet is now up to date with volume and surface area of a cone. Okay? 4 minutes. Next lesson we'll be doing some of the questions.